Yo, 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 this is Mr. O. Yo, 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 this is Mr. O, and today we're going to learn about reflection. What is reflection? Just when when you go to the restroom, you see the mirror of yourself. Yourself is the pre-image, and what you see on the reflection in the mirror is your image, okay? And that mirror is called your line of reflection. So a reflection is a flip over a line called the line of reflection, or that's the mirror. Okay, each point and its image are the same distance from the line of reflection. So if I have a mirror here in front of me, the distance of my nose to the mirror will be equal to the mirror to the nose that's reflecting, or the image of that. A reflection is also an example of a rigid motion. Okay, so if the line of reflection is right here, this is the original one. The image will be this orange here. And that should have equal distance from B to the y-axis and B prime to the y-axis. Same thing with the A to the line of reflection up to A prime to the line of reflection. Okay. Common lines of reflection are the y-axis or x-axis. Also for vertical horizontal line, they use x equal to a number. If it's x equal to a number, it's a vertical line. And if it's y is equal to any number, it's going to be a horizontal line. Diagonal lines are sometimes used. For example, the identity function y equals x, or y is equal to negative x. Remember this formula here. If you're being asked to reflect an image or pre-image about the x-axis, if you're given xy, the formula will be x negative y. So you just make the y negative or flip its sign. If it's about the y-axis, if you're given a coordinate, you flip the sign of the x coordinate. If you're given a diagonal y equals x, just swap the y and the x. If you're given y equals negative x, which is negative, swap them, but make sure you reverse their signs. And if reflect over the origin, you just make them negative for both coordinate. And also remember, if you are given a horizontal or vertical line, make sure it's equidistant from the pre-image to the line of reflection at the same time with the image to the line of reflection. I'll show it to you here in this example. Let's go ahead now. So graph and label each figure and image under a reflection in the given line. Give the coordinates of the image. So we have here triangle ABC with vertices -4, 2, -4, 1, 2, 3, 4, up to right there. That's my A. And B is 4, 7, 4, 7, 2, 4, 6, 7. This is my B here. And C is 5, 1. 4, 5, 1. This is my C. And let me connect them all. That's my triangle. According here, it should reflect over the x-axis. The x-axis right here. So you have two ways here. Either you find the distance of point A to line of reflection, which is 2 units. I can go down here too, also here. That will be my A prime. Another way is use the formula. It says here if it's x-axis, I'm going to just change the y value, its signs, okay? So if A is -4, 2, my A prime is -4, -2. My B prime will be 4, 7. So this will be 4, -7. And C prime, which is 5, -1. So I will just plot the points. -4, -2 is already there. Again, they're equal distance here. That's 2 units only. 4, -7, down 1, 2, 3, 4, 5, 6, 7. That's my B prime. And C prime is 5, negative 1. That is my C prime. And I will connect them all. And there you go. That's my image and pre-image, and its coordinates reflected over the x-axis. Let's do the y-axis this time. Let's say we have a rectangle PQRS with the vertices of 1, 2, 1, 2. That's my P. Q is 2, 5, 4, 5 is right here. S 8, 3. So 2, 3, 4, 5, 6, 7, 8 3s right here is my R, and S7070. That's my S. So now going back, when you're being asked to reflect over the y-axis, the formula, you change the x coordinate to flip its coordinate sign of the coordinate. So the 1, 2 will become now, the P prime will be negative 1, 2. The 2, 5 of the Q will be now, the Q prime is negative 2, comma 5. The R is 8, 3, so this will be negative 8, 3. And the 7, 0 will be negative 7, 0. So let's plot the points. Negative 1, 2, right there. That's my P prime. Q is negative 2, 5, right there, Q prime. Negative 8, 3 is right here, the R prime. S is negative 7, 0, S prime. And then connect them all. And the line of reflection, don't forget, you can draw that dash or dotted line there. There you go. Very simple, right? Now, what if we're given a triangle XYZ with vertices negative 5, negative 2, negative 3, and 4 for the y, z, negative 1, 1. But this time, it reflected the diagonal y equals x. So the first thing we're going to do, let's plot the point. Negative 5, 2, 1, 2, 3, 4, 5, negative 2. That's my x. Negative 3, up 4. That's my y. Z is negative 1, 1. And so therefore my triangle XYZ is right here. Again, going back, the formula, if it's about y equals x, just flip the y and x. So get the inverse of that. So the x prime will be now negative 2, negative 5. The y is 4, comma, negative 3. And the z will be 1, negative 1. So negative 2, negative 5 is right here. That's my x prime. 4, negative 3 is right here. This is my y prime. And z1, negative 1, it's my z prime. I connect them all. And where's the y equals x? It's this, I'm going to use different color. This blue one here. It's a diagonal that goes to 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, or this dotted blue lines here. That's my y equals x. Okay? Kaboom. And what if we're given parallelogram C, D, E, F with vertices negative 4, negative 4, negative 2, 0, 6, 1, and 4, negative 3. But this time, it reflects over the line y equals 2. So first, let's plot the points. Negative 4 is right here. That's my C. Negative 2, 0, that's my D. E is 6, 1, 2, 4, 6, 1, that's my E. And 4, negative 3 is my F. So my graph will be right here. Look, that's an ugly one. It's connected properly. Okay, a nice parallelogram. Okay. Now, where's y equals 2? The y equals 2 is right here. It's a horizontal line. This green dotted line here. That's y equals 2. Since it will reflect on the y equals 2, it does not reflect, it reflects on top of that line, okay? So how far is the 2 to the green dotted line. This is only 1 unit. So I'm going to do 1 unit also on the same level of the x. So this point here, the E prime, will be now same x coordinate. This will be, the E is 6, 1. So it will also be 6, but this will be move, just say 1 unit, okay? This 1 unit away from the dotted line. So this is now going to be 6 and comma 3. Why is it 3 here? Because if you plot the points, right? 6 to the right, 3 up. 1, 2, 3. Okay? For D, D here is originally negative 2, 0. So what I'm going to do with that one? You cannot just say you're going to add 2 there because the distance of this point to that one is 2. So the distance of this line of symmetry to the D prime should be 2 units also. So the D prime should be there. That will be now negative 2, 4. Okay? Because the distance of this point, D prime, to the line should be 2. Same thing with that. Okay? For the C, negative 4, negative 4, again, the x value does not change here. So it's still going to be negative 4. But the distance of this black point to the green one, to the line of symmetry, will be 1, 2, 3, 4, 5, 6. So I have to go 6 up of the 2. 1, 2, 3, 4, 5, 6. So that point is your C prime, which is going to be negative 4, positive 8. And F, which is right here, which is how far the x value or x coordinate is 4. It will not change. But the distance of that one to the green will be 1, 2, 3, 4, 5. So I have to go up 5 of 2. That will be 7. And there you have it. That's how you find the coordinates of the image if it reflects over the y equals 2.